Hey, everybody. I am Scott Bowe. I am a Senior Cloud Solutions Architect with VMware. I'm also VCDX number 275 and a 3x V expert. And today we are going to be talking about how you can use vROPS and vRA better together to do less work. So we are going to talk today about three things. We're going to talk about the problem that we have, the problem we're going to solve, how we solve it, and then we're going to go through a quick live demo of the solution in action. So what is the problem we are trying to solve today? Well, let's put ourselves in the position of a hypothetical IT person running a web infrastructure. And we've got our web store up and running and everything's hunky-dory. Those marketing folks go off and say, hey, let's have a sale. But what happens when you're in IT? You don't find out about those things. So then what happens is madness ensues, and you get all sorts of craziness as you try to figure out how to scale the web infrastructure and how to make your service run better. So we're going to talk about how we solve that problem today. Our solution involves a couple different products in the vRealize suite and then the core vSphere suite. And what we're going to do is we're going to talk through each of the different pieces of it. And then we're going to go through and examine what this looks like in the products. So the first thing we have is in our vSphere environment, we're going to use vSphere tags. And we're going to use vSphere tags to identify our servers and let the vROPS know what is it that they're monitoring and give them special information about it. Inside of vROPS, we're going to use a bunch of different things. We're going to use what we call custom groups, where we go into vROPS and we create a group construct that is filtered based on certain characteristics. And in this case, we're going to use the vSphere tags that we're going to talk about. And then we're going to use a custom monitoring policy in vROPS to define special rules for the servers that belong to our custom group. And then we're going to create a special alert, and that alert is going to consist of some special symptoms, which is a state that vROPS observes where we want to do something about it. So in this case, it's going to be focused on a certain threshold of CPU usage. And then we're going to create from that symptom an alert that says, hey, when our specially monitored server has CPU utilization over a certain point, we're going to then execute a vROPS action. And a vROPS action is a predefined through a management pack, such as the vSphere management pack, or maybe one of the True Visibility Suite management packs, or through a connection to vRO. And what's going to happen is that action, and that is going to combine with a recommendation to go execute a vRO workflow that is going to go out and examine our infrastructure, determine its current state, and then reach out to vRealize automation through the API and submit an updated change request to our cloud template that deploys our infrastructure. So those are the different pieces of our solution. So now what we're going to do is we're going to move into what does this look like in practice, is that we have our website, it's up and running, and marketing throws that sale out there. And we this time we don't have to struggle because vROPS detects that, hey, our open cart, our front end CPU utilization is high. Let's do a scale out event. And it's going to reach out to vRealize automation. It's going to update our infrastructure, and away we go. So with that, I'm going to switch out of the PowerPoint, and we are going to go to our VDI session and walk through these different components of it. So here we are in a VDI lab environment where this demo, this scenario is up and working. So we're going to walk through what this looks like and give you a quick lay of the land. And then we're going to walk through what this actually looks like. So the first thing we have here is we have our vRealize automation endpoint. And we're currently in Service Broker, which is the end user catalog. And when we see this as the end user, I click on deployments, we can see that I have a couple instances of my application deployed. I have a sandbox one, and I have one that's declared as test and PCI. And then I have a vSphere instance up that is 2 linked vSphere instances running a bunch of virtual machines. And here you can see I've got all my virtual machines up and running. And then the last thing that we have up that we're going to walk through is our vROPS environment. So let's walk through all those pieces of our solution in order. So the first thing that we have is in vSphere, what we define in vSphere is a special vSphere tag. And what we look at is if you go to menu and policies, menu, then tags and custom attributes, we have our tag categories, and one of our tag categories is called server type. And this is a tag category that we've created that we're going to use in vROPS for other purposes. And we have a specific tag inside of this called front end. And if we sort it by alphabetical here, we can find that we have our category of server type and the tag of front end. So that is our tag that we've defined in vSphere. And if we go back and look through our virtual machines, we're going to have one of them have this tag on it. So we can scroll through and this one doesn't have it. This one doesn't have it. This one doesn't have it. But here we should find one of them here that does. Here's one 6222 that has our defined front end tag. So this tells us that this is our web server. So how does vROPS consume this information? So if we hop over to vROPS, you'll recall that the first thing that we talked about in vROPS is that we were going to create a custom group. So under environment in vROPS, we have a section called custom groups. And custom groups, we have one called function. And this is a group type. And you can see I've got a couple of them defined here, one for CentOS, one for Lab VM, Lab Host, and here I have one defined for OpenCart Web Front Ends. So the OpenCart Web Front End is defined by going to actions and editing the group, and we can see the criteria that it has. So we can see that this is defined by the criteria of contains virtual machines that have the tag of category server type, and then that category contains front end. And we have this box check that says, keep this group up to date. So what this means is that vROPS is going to continually look at our environment as it collects data. And as it finds new virtual machines that meet this criteria, it's going to add them to the group. And conversely, if it finds virtual machines that have been removed from the environment or remove that tag, it's going to remove them from this group. So this is a very dynamic way of applying this rule set. And then you can see we are specifying that members of this group have a specific policy attached to it. If we expand this pull down, we can see that there are a large number of policies available to us in the environment. We have our default policy, the solution default policy. We have one for snapshot lifetime exceptions, and we have one for auto scale. So that's how we define this is the machines that we want to apply this to. So let's go talk about the next couple of things on our list from vROPS is the alerts and symptoms and recommendations. So inside of vROPS, we have a number of things that make up how vROPS reacts to certain events. The first thing that we do in this scenario is we have our symptoms. And we have a number of symptoms here that some are built in and some you can see are custom. So we can filter it based on front end. And you can see we have two different symptoms here. We have one for OpenCart Web Front End workload is high, and that's defined as a virtual machine has CPU demand greater than 40%. And then we have another one that goes along with this, that CPU demand is low, which is defined as less than 10%. So what this means for us is that as vROPS is looking at this environment, when it sees a virtual machine that's tagged as web front end with CPU utilization as higher than 40%, it's going to trigger this symptom. And so what does vROPS do when this symptom is triggered? It's going to look at if there's any alerts defined for this. So we'll filter again on our alerts. And again, we have two alerts here, one for high and one for low. And if we look at the definition of the high alert, we have it defined as we have a symptom associated with it for our front end workload is high. And then we have mentioned that this is going to apply to the auto scale policy. So that's the policy we saw defined in our custom group. And then last thing that we'll see on this is that there is a recommendation associated with this. And that recommendation has a description of scale the open cart web front end with an associated action of scale out. So when this alert triggers, what is this recommendation? How do we get to arrive at this? So if we hop down to recommendations and we look at our recommendations, we have our scale in open cart front end recommendation and our scale out. So if we look at the definition of this, in recommendations, you can have it be as simple as defining a link to instructions that the user should execute when this alert occurs. Maybe this is simply a link to an internal knowledge article, or it's detailed instructions on what you should do. In this case, we just have some simple text. And what we're most importantly doing is we're pointing at our orchestrator adapter. So we've established a connection between vROPS and vRealize orchestrator, and we've told it, go execute this workflow. And so that's that recommendation. So when this alert occurs, we can see that I have a couple of alerts for web front end CPU is low. And here you can see we have our 6222 that we observed in vSphere was a front end. We can see that there's an action associated with this. So now we've given the user the ability to push a button to remediate this. So what happens if we want this to occur automatically? How can we use vROPS to do that? Well, if we go over to administration and examine our policies that are defined in vROPS, we can see that our auto scale policy is a child of our solution default policy. So it is inheriting all the settings and values defined in our default policy with two local changes. So this works, if you're familiar with Microsoft Active Directory group policy, works very similarly. There's inheritance, and then there's local overridden policies. And what you can see on this is it's saying machines monitored by this policy have these two alerts enabled. So we are saying that any machine that meets the criteria of this policy, which are members of our custom group, are going to have this alert enabled. And we then subsequently said, automatically perform the remediation. So what that means is when that alert occurs, vROPS will attempt to resolve the problem by going and executing the defined action. And just to give you an idea of what actions are possible out of the box, if we click on actions, we're going to see that I have several hundred of them in my environment. Some of them are from Orchestrator, or I guess I only have 89. I apologize. You have several that are built in from just by connecting to vSphere. So deleting an idle virtual machine, deleting a powered off machine, and then you have the ones that we've gotten from Orchestrator. So what does our Orchestrator action look like? Well, before we do that, before we go over to vRA and look at Orchestrator, I'm going to kick off some load onto our web environment to see what this looks like. So I just have Apache Bench running against one of my web servers. And so now while we go do some other things, that's going to go kick off and run. So let's go look at the vRA piece of this puzzle. So inside of vRA, we have a number of services. And the one that we're going to be going into first is called Cloud Assembly. And in Cloud Assembly, we're going to look at the cloud template for this application, which is our MOAD OpenCart cloud template. And the key thing to take away is that this defines our entire application of a network that gets provisioned by an integration with NSX, a jump box that's provisioned to give us access, a SQL server that's provisioned and has MySQL installed through Cloud Init, and then several web front ends that are installed with Cloud Init on it. The key part on this is you can see that there is the ability of, it's indicating that there could be multiple web front ends. So on our input that the user is providing, we're giving them the ability to define small, medium, or large for our front-end cluster size. And as vRA executes this template when it's requested, it uses an expression language to translate our input to either 1, 2, or 4 servers that get deployed. So when we submit a deployment based on that, 1, 2, or 4 web front ends are deployed. So now, as a user, I've deployed it with a small front end. We have the vROPS monitoring enabled. How do we enable vROPS and vRA to modify this request when it's needed? So then to do that, we go to Orchestrator. So in vRealize Orchestrator, we have a number of workflows, and we'll look at this auto scale in workflow because that happened recently, and this one looks like it failed. But what we want to see on this is the actual code of it. And when we look at the code of this, we have a scripting step that's in JavaScript that is breaking apart the inputs from vROPS to determine the affected virtual machine. And we have then an action that's executing. And this action is actually written in PowerShell. So one big feature of vRealize Orchestrator when used in conjunction with vRA is that you can write your scripts in multiple scripting languages. You're not just limited to JavaScript. So our action is receiving the input, generating an API token to log into vRA, and then it's debugging some information right to the log. And then it starts to walk through the vRA API to determine, hey, we need to find this virtual machine in vRA and get information about what is it associated with. So once we find the machine, we need to go find the actual vRA deployment, the wrapper around which our application that sits around our application that's deployed by our cloud template. Then we find our deployment after finding the virtual machine, and we then look at the submitted inputs of our cloud of that deployment to find out what was the cluster size that was there. And then based on that current state of that cluster size, we have a simple switch statement that says, hey, if it was a large, it should become a medium. If it was a medium, it should become a small. If it was a small, just write some debugging information to the log and stop doing things. And then from there, our orchestrator workflow submits a API request to vRA to modify our deployment and add or remove a node depending on what we have happen in vROPS in the detected state. So now that we've walked through all the different pieces of it, let's go see what this looks like in reality and if how this actually executes. So we'll come back to our deployment, and it appears that if we look in vROPS, our alert hasn't triggered for high CPU yet. We're still in the state where it was low a little while ago. So, but we can look at the history because I did this several times preparing for this. So we can look at our history and we can see earlier today, I created this deployment and I deployed the jump box, the MySQL server, and a single web front end. And then after introducing some load to the environment, it deployed, the alert triggered, and it was using an ID from vROPS, and it deployed an additional front end. And then a little while later, after the workload scaled back, it removed that added node. So at the end of the day, we've now taken vROPS, monitored our environment, created a script inside of vRealize Orchestrator to solve the issue that we're detecting, and then leverage the application authoring in vRA to simply modify our application in a way that solves our alert, remediates it, and brings us to a state where we can continue to provide positive service to our customers. So that's the end-to-end demo of that. And we'll take one last look to see if the timing of everything worked out for vROPS to detect high CPU usage. And it looks like, unfortunately, we haven't, but we might check back one more time. But what I want to do now is I just want to show you where you can go to build this on your own. So one other thing that you can do, and another talk that I'll be doing as part of this series, is how can you do a similar thing but have vRO and vRA automatically search and destroy snapshots in your environment. So that'll be another session, another presentation. And then, so lastly, in closing, you can go to my GitHub repository where I have the orchestrator code to perform these actions that you can install in your orchestrator environment. The cloud templates also exist there. And then I also have this written up as a blog series on my blog where you can go out and you can read the instructions of how to walk through and set this up to do a proof in your environment. And that's it. Thank you for coming and listening, and I hope this was helpful.